We're back with our program that creates Winston's, but I've added a new object type, Hopper, because Hopper was feeling a little left out. Now I define Hopper the same way that I define Winston, starting off with the constructor function and takes in the same properties and then draw and then talk. And then I also added another method called hooray, because Hoppers really like to celebrate and Winstons don't really at all. Now at the bottom of the function, I've created two new Hopper objects, Little Hopper and Big Hopper, and drawn them and called talk on one and then hooray on the other. So that's pretty neat. Now, if we look at this code up here, you might notice something interesting, is that the code for Hopper is very similar to the code from Winston. In particular, look at this constructor. I don't know if you remember, but that is exactly the same code as our Winston constructor function. And then this talk function is also exactly the same code as our Winston talk function. And they also both have draw functions. So there's a lot of things in common about these two object types. And that makes sense because, Hopper and Winston, they're two very similar object types in our world. And if you think about, the real world, like outside the computer, most object types share similarity with other object types. Like in the animal kingdom, all animals are similar in some ways. And then, we have different types of animals like humans. And humans share those similarities, but also have their own unique similarities. So we could say that animal is an object type that human object types inherit functionality from. So we don't completely start from scratch, we add on top of the functionality that we get from being an animal. Like all animals make noises, but humans also make language. So this concept of object inheritance is really useful in programming too. And we can create a chain of object inheritance in our JavaScript. So to do this, we need to think about what's shared about our object types and come up with a name for that because we're going to create a new object type that represents the base object. So let's call them creatures. They're both creatures. So we say var creature equals, and now we need our constructor function. So let's go and just steal hoppers since that's the same thing as Winston has. All right, and then let's see, now we want to, what do we want to do next? Maybe we want to add the top function on it, right? So talk function, we could just steal hoppers, but of course we need to have it on the creature prototype instead. Okay, cool. So now, now we have this creature object type, but we need to actually tell Hopper that Hopper should actually base its functionality off of creature. So we can do that by writing this line here. We'll say hopper.prototype equals object.create creature.prototype. So what this line does is tells JavaScript to base Hopper's prototype, so to base all of Hopper's functionality off of the creature prototype. And then that means that every time it looks for a function on a Hopper, it'll look at Hopper's prototype first, but then if it doesn't find that, it'll actually look and see if it was on the creature prototype. And this is what we call the prototype chain. Now, once we've done this, we should actually be able to delete the talk function on Hopper because it already exists on creature, which is up the prototype chain. So let's try it. Ready? Dun, dun, dun. It worked. And it works because it finds it on creature prototype instead. So let's try deleting it on Winston too. Okay, it didn't work. It says object has no method talk. And why is that? Well, we have our Winston constructor and draw, and we took away the talk. Well, you notice we forgot to actually tell Winston's prototype to be based off the creature prototype. So we need that very important line, winston.prototype equals object.create creature.prototype. Ta-da! And notice something important. I have this line after the constructor function, but before I add anything else to the Winston prototype. So that's usually what you want to do is you want to tell it, just as you're starting off immediately, all right, this is what your initial prototype will be based on, but then we can keep adding more stuff to its prototype because there could be some things that are unique to Winston's and are unique to Hoppers that aren't on creatures, and that's totally cool that you can define those. All right, now if we look at this, we still have some repeated code, the constructor code, right? We have this all 3 times. So could we just delete it? Let's try it. Okay, doesn't seem like that worked because our hopper shows up in the upper left corner. It kind of forgot everything about itself. And this is because JavaScript does not assume that you want the same constructor, even if you want to base the prototype off of it. Um, it lets you define your own constructor for these objects, but it also doesn't give you an easy way to call a constructor from a sub-object. So the way we can do this is we'll write creature dot call this, comma nickname, comma age, comma x, comma y. Okay. Now what this does, notice it worked, yay. And what it did was it actually is calling the creature function, the constructor function, is calling that function, but it's passing in and saying, okay, you should call this constructor function as if it was being called from this hopper object, and as if it's being called with these arguments. And these are the arguments that the hopper got called with. And that'll end up just executing this code as if it was right here. And that's exactly what we want. And it worked. And we can go ahead and copy this line into the Winston constructor too. And it works. Yay. All right. So check this out. We've encapsulated all our shared properties and functionalities about objects in this single base object type, creature, and we've made two object types that extend from that base object. They inherit some functionality, but they add their own too. And the cool thing about this is that we can change the shared functionality in a single place. Like if we wanted to change age again, we say plus years old. Cool. Now everybody has years old at the end of it. Or we could change the top functions. Be like, yo, sup, woo. All right. And now both Winston and Hoppers are saying sup. So now that you've seen how to create object types and inherit from object types, you can start thinking about how this might be useful in your drawings and animations and simulations and games. For example, maybe you have a game and you have many types of characters in it, and all of them can run, but only some of them can jump. That's a perfect place for some object types and some inheritance. But I bet you can think of tons of more ways as well.